All right, today we're going to talk about arithmetic series. We did just finish talking about arithmetic sequence, and we've already alluded to what this is. It's the same concept, except for we are going to add each term as we go. I want to point out a couple of things on this home screen as we're looking, one of which is the sigma notation that we see down in the bottom. You'll find other formulas, but we're going to just kind of stick to the sigma notation. But in order to use that, we've got to kind of identify what these things are. Notice the summation sign. We'll talk about that in just a minute. But below it, we're always going to put, in our case, we're with a TI-83 or TI-84, we're going to use an X, not an N. But we're going to set that equal to the starting term. Most of the time, the starting term is 1, but they may give us one where we are supposed to start at 4. The next thing we have is the part above the sigma, which is the ending term. So if I'm looking at this sigma notation right here, what this is telling me to do, this summation sign that we see here, is to sum all of the terms between 1 and 34. That's what this whole left side is telling us. Now, the way that we get that is based on the rule. This is also known as the explicit formula, what we were talking about, but you also may be known as the rule. So we will have to run all 34 of those terms through this. Now, we're not going to do that. What we're going to do instead is put this into our calculator and let it do the work for us. These examples I'm going to walk you through today are the first 5 examples that you're going to see on your Canvas assignment. And we're going to have to use a calculator to do many of these, but we're going to read through and kind of get an idea for this. So it says evaluate each arithmetic series described below. Well, the first thing we need to identify is what kind of an they told it's arithmetic, but we need to also figure out what our common difference is, the change that takes place each time we move 1 unit to the right. So from 7 to 12 to 17 is a common difference of plus 5. Now what this is asking me to do is to, again, it's a series. It wants me to add up the first 18 terms in the sequence. This is the first term in the series, second, third, fourth, and they want me to go all the way up to 18. Now I could list all 18 of these and add each of these all of the way, but what we probably want to do is create our formula. And the first thing we're going to need to do is we will go to the sigma notation. It's an E looking symbol just like this. And what we do is we surround it with the parts we talked about. We are going to start this series at the first term because we weren't told otherwise. And we are going to go to the 18th term in the sequence, which is right here. So this is how and this tells a whole story right here of what we're doing. We're adding up 18 terms in a sequence from 1 to 18. And then the next thing we need is our explicit formula or our rule. Now this is what we created yesterday using that formula. Remember the a sub 1 plus the common difference times n minus 1. So in this one, our a sub 1, the first term, is 7. Our common difference is 5. You're going to be tempted to put in 18 here, but we are not just substituting in 18. We're substituting the first 18. So we're going to leave this formula. Since I said x here, I've got to say x here. 1. So that is the explicit formula. Your calculator is fine and good if I come over here and put it in just like it reads. And we'll show you the calculator in just a second. But if you do not see this answer, what they're probably looking for is for you to distribute the 5 and then combine like terms. So if you don't see the answer that you have, that's okay. You may need to just simplify. So the rule is either of these two, your calculator knows the difference. 5x plus 2 or 7 plus 5x times x minus 1. All right, now that we have all that, what we're going to do is simply take this information that we see here on the right and put it into our calculator. All right, so we can do this a couple of ways, TI-83, TI-84. I'm going to show you TI-83. The first thing we're going to push is the math button. And if you'll scroll down, you'll see under option 0, you have summation. But there's a faster way on the TI-84s. If we use the alpha button and then follow that with F2, you can see that the second option there is summation. We're always going to put where the series starts there, x equal to 1, and we're going to put where the series ends at the top, which in this case is 18. Now, we are going to put the explicit formula or the rule in the set right here. So I'm going to do it both ways actually. The rule we're going to put right here, 7 plus 5 times x minus 1. And then our answer is going to pop up right here. You may have to hit enter on this. You will have to hit enter on this actually. And we're going to check the other way as well. It's the same process. We're just going to put in a different rule because we had the rules there. So that was alpha F1, F2 again, excuse me. And this time we're going to use the rule 5x plus 2. But again, you see that the answer comes out to 891 because it is the same thing. So that's how we use our calculator to solve these. So we have as an answer here 891. And again, just to refresh, 891 is adding up the first 18 terms in this sequence. We don't want to do that by hand, so trust your calculator. So this one, we're going to do the same thing. We're just given different information here. Last time we were given the series and we were asked to find the common difference. On this one, we have that information. We've just got to create our formula. So our summation here, and it wants the arithmetic series. Unless we're told otherwise, we're going to start at the first term in the series. So surrounding our sigma sign is going to be x equal to 1. And then as you can see, we are going to the 11th term. So what we've got to do now is create our rule or our explicit formula. And remember, that is the a sub 1 plus the common difference n minus 1. Well, this one, they just gave us the stuff. A sub 1, the starting point is 8. The common difference is 2. So this is n minus 1. So this is the value we will take to our calculator. It is completely up to you, but just be prepared if you're taking a test and you do not see this explicit rule, that you will probably need to distribute the 2 and then go from there. So I'm going to leave it in the explicit rule formula, and I will take this to my calculator. So you can see we're going to run this through our explicit formula. So as we walk through this, I'm going to hit alpha F2, and then the second option is summation. There we go, summation. We are doing the first to the 11th term in the series. So 1 and 11 go there, and then I just fill in my explicit rule there, or explicit formula, or rule, same thing. And we typed it in and let the calculator do the work from there. We can see we get a total of 198. So what we have here is 198. We'll probably stay away from the calculator on the screen from now on. I'm going to do it here beside me. If you've got questions, make sure you ask. You've got to know how to do this on your calculator. Now this particular question, we are literally just doing it in our calculator. So we'll go through the same process, alpha F2. Summation is the second option. This one it's asking me for, remember, use X, don't use N on your calculator. Your calculator doesn't understand N. And then we just type in for, again, X, not for N. Put in our calculator, hit enter, and our result is 4,140. I'm going to give you guys just a second to make sure that you can do this in your calculator. I'll walk around, take a look, make sure that we are actually getting that number, because if you can't use your calculator, you're going to have some major issues. All right, guys, we're not going to get into heavy formulas on this particular one. Really, one of the best things we can do is just guess and check on these. So we are still using the same formula. It is a summation formula. This one is an interesting one because they're giving us the solution 2650. We know we are going from the first term of the sequence, but we don't know where we're going to. We also know our explicit formula. Our explicit formula starts at 4, has a common difference of 2, and then we have n minus 1. When it goes into your calculator, it's going to take a look at this, look like this. Remember, don't use the calculator's parentheses. If you want parentheses, create your own. So I'm just going to take a guess on what this is. Well, let's see, what if we had the 20th number in the sequence and see what comes out. So I put 20 in here in my calculator. I'm not going to go to and show you my calculator. I'm just going to put the result. When I put that in my calculator, it's 460. Not nearly close enough. All right, so don't retype everything. If you'll hit second entry, that's the second enter button. Put that down here for you. Second, and then the enter button. It will pull up the last formula that you wrote. Well, that's helpful because all I'm going to do is go back into my formula and change the number. Let's try the number 40, for instance. So whenever I go second entry and I change the number to 40, obviously it's going to be higher. I say obviously, but remember, the numbers can go down if we have negatives. When I do 40, the outcome is 1720. So 40 is clearly not my answer. And then I will check another one. Let's go up to 50 because we're pretty close. So when I go to my calculator and I type in 50, the answer that comes out is 2650, which is what we're looking for. So again, it's just price is right. Too high, move down. Too small, move up. And then we get our answer 2650, and that happens when n is equal to 50. Trial and error, guess and check. I really think that's the best method as we're moving through these. The last one we're going to take a look at today is one where we're asked to do the series. We got to do a little reasoning here. Now, one thing I want to point out is this substitution method tells us this. This says a sub n. Well, it tells us that n is 14, so a sub 14 is 130. All right, so we are going to the 14th term, the sequence. So if we started to put our stuff together, what we would have is we would have the starting point of 1, the ending point of 14, and as far as the explicit formula goes, we have the 13, plus we do not have the common difference, and that's what we're going to have to find. Now, we're going to find the common difference just like we did with the series yesterday. Remember this, we are going from 13 to 130. So 13 to 130 is a change of 117. Our number has gone up by 117. Now here's where you got to think. How many steps have we taken to get to this amount? We are at step 14, but remember we started at 1. So if we went from 1 to 14, we've actually only taken 13 steps. So if we've traveled a total distance of 117, and we've done it in 13 steps, each step is 9. And what I'm describing as steps is called our common difference, isn't it? So we have a common difference of 9. So we would go back in here and we would substitute into our formula here d with the number 9, because that's what our common difference is. I'm now going to take this value to my calculator and put this together. Going in here from the first number in the sequence to the 14th number in the sequence, because that's what they told us, and starting at 13 plus 2, 9 times x minus 1. So when I put this into my calculator, what I get is 1001. This is one of those topics where you show your parents, guys, it looks really hard, looks really fancy, but I'm not doing a whole lot of work, my calculator is. Make sure you recognize that. There's a few steps that go involved in some of these, and some of you, again, are going to like this because it involves some problem-solving skills. So show me your problem-solving skills. All right, you've got the rest of those examples. If you got questions, make sure you ask. Good luck.